Okay, student notes video lesson 5.4, sum and difference properties, day 2. Okay, we're going to see another way that we can use these sum and difference properties. It would probably be a good idea if you had out your trig identity sheet, which is blue, and that way you can refer back to these formulas as needed. Okay, so let's just jump into example 1. It says, if sine of A is 1/2, cosine of A is greater than 0. So they give us some information about this missing angle A. And tangent of B is 3/4 and sine of B is less than 0 or negative. So they give more information about another angle B. It says find the exact value of sine A minus B. Now we don't have to actually know what angle A and angle B are to do this. We definitely could use some inverse trig properties to find angle A without a calculator. To do this though for B, I would have to have a calculator and approximate the value. And what we're going to be doing on these notes is we're going to find exact values, and it even says here exact. That means no approximating decimals. This means using all of the things that we know about special right triangles and the unit circle and everything else like this. So we're going to use the formula for sine of A minus B. All right, and that is, that is going to be sine A cosine B. I'm getting this off of the trig identity sheet. And then minus cosine of A sine of B. Okay, so again, I don't have to know exactly what A and B are, but I need to know these 4 things about angle A and angle B. So over here off to the side, I'm going to draw what I need. Now, I know that sine of A is positive, and I know that cosine of A is positive. So what is the quadrant where sine and cosine are both positive? Okay, quadrant 1. Now, I'm going to go ahead and draw this in quadrant 1. You could just write down that it is in quadrant 1. That would be totally fine. And so if here's my angle A, opposite would be 1, hypotenuse would be 2, and this would give us square root of 3. And now you know what angle A is. Like I said before, we could use arc sine of 1/2, and that would be 30 degrees. So that won't happen in every problem though. But in this case, now I have enough information about A so that I can find, I already know that sine of A is 1/2, but now I can also find cosine of A, which is square root of 3/2. I can use the triangle, or I could have used the fact that A is 30 degrees. But again, that won't happen every single time where it's an angle you can actually figure out. All right, so now we need to figure out this information about B. Okay, I'm given tangent of B. That doesn't help me with cosine of B or sine of B. And then I'm also told that sine of B is negative. So tangent's positive and sine is negative. Which quadrant is that? Okay, it's quadrant 3. All right, so I'm going to go ahead and draw my B in quadrant 3. I could have just written that it was in quadrant 3. That would be fine as well. And so if tangent of B is 3/4, then that means the opposite here would be 3. The adjacent would be 4, and this would be a 3, 4, 5 triangle. Now actually 3 and 4 here are negative 3 and 4. When I go through and do cosine of B and sine of B though, I already know that those values are going to be negative because it's in quadrant 3. All right, so cosine of B, that would be 4/5, or you could say it's negative 4/5. All right, sine of B is going to be 3/5, or negative 3/5. All right, once you get these 4 values, all you're really doing from here is just the arithmetic. So this would be negative 4/10, and then minus a positive times a negative, that's going to be plus, and I'm going to write this as 3√3/10. Now, if you do this right, you're going to have a common denominator. So this is one reason why I didn't write this as negative 2/5. It's already written the way that I want it so that I can combine it into a single term. Now I'll show you why. Let's finish writing this and then I'll explain why that would be important. So here's my answer. Negative 4 plus 3√3 all over 10. The reason this is important that we write it this way, it would have been okay to write it a different way, meaning leave it as 2 different terms. But what if I turned around and then said, okay, now I want you to find cosecant of a minus b. In the form that my answer is right here, it makes it really easy to find cosecant a minus b. Well, it's just going to be the reciprocal of sine a minus b, which is what I found here. So cosecant a minus b would be 10 over negative 4 plus 3 root 3. I just took the reciprocal of the whole thing. Okay, and that could have been another part of this problem, and we'll see more of this in a second. Okay, so let's look at example 2. It says find the exact value of, and first it says sine of 15 degrees. Now, we do not have a special right triangle that has 15 degrees in it, but we do have special right triangles with some things that subtract to get 15. Okay, so the whole first part of this problem, let me just go ahead and write this down here. Let me rewrite sine of 15 degrees. The whole first part, if I can find A, then I can easily find B and C, or I should be able to, using properties and identities and things like that. All right, sine of 15 degrees is the same as sine of 45 minus 30. Both of these in degrees. All right, and using the sine A minus B formula, okay, this is going to be sine of 45 cosine of 30 minus cosine of 45 sine of 30. Okay, this is just like sine of where A is 45 and B is 30. Okay, it's this very, very similar thing I did in example 1. But here I don't really need to draw a triangle. These are exact values, and this is another reason why we keep practicing this. Sine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. All right, cosine of 45 is square root of 2 over 2. And sine of 30 is 1/2. All right, so now let's combine these. We've got square root of 6 over 4 minus square root of 2 over 4. And this simplifies to square root of 6 minus square root of 2 all over 4. Okay? And that's your answer. Now, if instead of square root of 2 over 2, if you had used the unsimplified radical 1 over square root of 2, your answer would have come out differently here. I really don't think many of you would have done that, but if you worked this out slightly differently, you could have gotten another answer here that was equivalent. Okay, I'm going to go ahead and work with, though, what I think most of you would do. All right, so that's the answer to part A. So part B is a very similar thing. It's just cosecant. Okay, so cosecant of 15 degrees would be the reciprocal here, and I'm just going to write that as 4 over radical 6 minus radical 2. Now, I realize that we have square roots in the denominator here, and that may bother some of you because you've been told repeatedly to simplify. At this point, we're not going to simplify this. There is a way to do it. It would take multiplying the top and the bottom by the conjugate here, but this is totally fine for now. And so we're just going to leave it like that. Okay, I want to concentrate more on the trig than the actual simplifying even. All right, now let's look at part C. Now, part C may seem like a completely different problem, but if you remember about cofunctions, sine and cosine are cofunctions. 15 degrees and 75 degrees are complements. So cosine of 75 should be the exact same as sine of 15. So my answer here is root 6 minus root 2 all over 4. And that's it. Okay, bring your questions to class, and we'll practice this in class.